So hello everyone. In this lecture we'll be seeing about depth sorting algorithm. The another name of depth sorting algorithm is the painter's method algorithm. So this painter's algorithm is a combination of both image space and object space. So I just want to remind you that the object space method we saw, backspace detection method, that is applied throughout for all the methods, that is which is a preprocessor. So before applying depth sorting algorithm or Z buffer or A buffer or scanline algorithm, we'll apply the backface detection method. Then we'll apply these image space algorithms. So this painter's method is an image space and an object space algorithm. It does two basic functions. So these two basic function is actually very important. It sorts the surfaces based on the decreasing depth Z value. So it sorts the surfaces based on the decreasing Z value. It scans and converts the surfaces starting with the greatest depth. So it does 4 tests. We'll see each test one by one. Okay. So the first one is test 0. In this what happens is, if there is a surface S dash and S, the Z max and Z min value must be there. So there must be no overlap between the depth. So this Z, we can see clearly that there is no overlap. That is, by means of overlap, what I am saying is that Z minimum is less than Z minimum dash. Okay. If test 0 fails, then there must be an overlap. Okay. So if test 0 fails, this surface needs to be here, so that there is an overlap. Then we'll go to the main tests. So the first test is the boundary rectangles in the XY plane for the two surfaces do not overlap. The second test is surface S is completely behind the overlapping surface relative to the viewing position. Third is the overlapping surface is completely in front of surface S relative to the viewing position. And the fourth test is the projection of the two surfaces of the view plane do not overlap. If all these tests fails, then what happens is we need to reorder our surfaces. So we will see each test one by one. So this is test 1. Assume take this figure as an example. See, if you can see S dash and S here, and the coordinates of X dash minimum, X dash maximum, X minimum, X maximum is given. Here there is no overlap in X values. Similarly, there must be no overlap in Y values. So if you project Y dash minimum, Y dash minimum, Y dash maximum, Y minimum, Y maximum, there should be no overlap. So this test fails if X dash maximum, that is this value, is greater than X minimum. If this value lies somewhere between this region, then it overlaps. Then we go to test 2 and test 3. This test 2 and test 3 is done simultaneously. That is, the test 2 is the points of S should be substituted in S dash plane equation. Okay, so take a point on S. Okay, so if we substitute, if the point after substitution, if the equation is equal to 0, then it is on the plane. If the equation is less than 0, it is inside the plane. If the equation is greater than 0, it is outside the plane. So in test 2, all points of S is inside the plane, then S is completely behind S dash. So if we take points in S and substitutes in X dash equation, then it will be less than 0. That proves that this S surface is completely behind the S dash surface. You can see this in test 2, test 1 has already failed. That is, it has an overlap between X and Y values. So if test 1 fails, we do test 2. So the test 2 figure actually looks like this. That is, S is completely behind the S dash. So in test 3, what we do is all points of S are outside and S dash is completely in front of S. So you can see here, this S dash is actually completely in front of S. Some points, if you consider some points that will be in front of S, if you consider some points of S and substitute in S dash, these points, so these points will be greater than 0, and this point, which is, if this point is substituted in S dash, it will be less than 0. So if this happens, then test 3 also fails. So what it says is, this S dash when substituted, if all the points in S dash is substituted in S equation, everything must be greater than 0. That is, this S dash must be completely in front of S. Then the final test is fourth test. This fourth test, we have two examples. This is one figure. This is the next figure. In this we can see the test 4 is not failing if the projection plane is not overlapping with the surface. That is, the projection plane is not overlapping, but the surface plane is overlapping. Okay. In this surface, we see both the projection also overlap, both the surfaces also overlap. So when test 4 fails, what we do is we consider that first we considered that S is in front of S dash. If all these test fails, we will consider that S dash will be in front of S. So the next method we will be seeing is area subdivision method. So in area subdivision method, the main thing what we are going to see is octrees. So actually what is happening in octrees is, if this is the window, it is actually divided into 8 parts. So it will be continuously divided until the last pixel is there. So that pixel's intensity value, depth value will be noted. So that is the octrees method, which comes under area subdivision. So this area subdivision is also an image space method. So we have 4 types. The first one is, if the window is actually inside this object, completely inside, then we call it as the surrounding surface. If it is an overlapping window, then we call it as an overlapping surface. If the object is actually completely inside the window, then it is known as an inside surface. If the object and the window have a good distance and there is no overlap, then it is known as an outside surface. Next we come to animation. Actually, we know what is animation. We have seen many pictures, movies, animation movies. This word animation has come from Greek and Roman origins, named animos or animo. The meaning of animos and animo in Greek and Roman is to bring to life. So if we bring a picture to life, that is known as animation. And animation is of 2 types. One is convection animation, another is raster scan animation. And animation has particularly many applications such as motion picture, cartoons, advertisement, scientific and engineering application, training and simulation, and education. So let us look into convectional animation first. So what is happening in conventional animation is a set of pictures that will run in a time. So this set of pictures is known as a frame. So what happens step by step in creation of conventional animation, we will see. So the first is storyboard layout. The second one is object specifications. Third is keyframe specification. And the fourth is generation of in-between frames. So the first is the storyboard layout. This is also known as the outline or rough sketch. So what they do in this is, they will do some rough sketch on how the animation is going to be. So this is a very important and a basic task. Next is object specification. So what all object is going to be presented in the animation, their properties, the characteristics of each object on the scene will be specified, and this object will be associated with movements. Okay. So the next thing is keyframe specification. We saw what are frames. Okay. So important, see, like this is one frame and this is another frame. These are also frames. So key frames are some important frames, that is 2 to 5 frames that will be initialized before any generation of in-between frames. So these are very important things. So example, if you take a frame in which a man is kicking the ball, the first frame is actually a key frame and the last frame which actually a key frame, in which the ball is near the man's leg and in the last frame the ball is actually moving away from the man's leg. So these two are known as keyframe, and all the frames that are in between the keyframes is known as in between frames. So this in between frames is actually used to produce seamless movement of animation. So we have two types. In 1 second, if there are 24 frames, then it is used in films, and if there are 50 to 30 frames per second, it is used in graphic terminals. The only disadvantage in convectional animation is it only does in 2D animation. Now next we will see computer animation functions. So there are three main computer animation functions. First is the wavefront. The wavefront is actually a package where all functions are there, such as database, zooming, keyframes. Database is where we store object and object characteristics and specification. Zooming, as we know, it is known as zooming in or zooming out. Keyframe is in between frames generated. Keyframes and in between frames are generated for seamless animation. Okay, the next one is raster animation. The advantage of raster animation is it can be used for 2D and 3D animation also. It uses raster scan display and raster operation. The color, it has a color table which specifies shape, intensity, color of the object at each pixel. So consider this this as pixel, and the object is here. The rest pixel will be covered in background color, and this will be in object color. So this is one frame, and in the next frame the object has moved from this pixels to this pixel. So this pixel will be set to background color, and this pixel which was previously in background color will be filled with the object color. So this is, so in the next thing we'll see computer animation languages, which is basically keyframe system. When keyframe systems are specified, we can generate in between frames. Next is parameterized systems allowed motion characteristics to be specified as a part of object specification. Script system, here motion and characteristic specification is given as by the user as a scriptic input. So we'll see one more important concept known as keyframe system. So in this, what happens is keyframe systems is classified into two. One is kinetic description, another is physical description. Kinetic description is described in a set of spline and Bezier curve equation, whereas physical description is described in terms of force equation. Okay, so the last one is morphing. Morphing is changing of shape of object from one frame to another. So if the initial object looks like this and the final object look like this, the transition from initial to the final takes place in many frames. So first the initial object becomes this, then it becomes this, then finally it becomes the final object. So this transition, this in between frames, is known as morphing. So with this we have come to an end on animation topics. In the next video lecture we will be seeing surface rendering methods such as shadowing and lighting methods. Thank you. With that surface rendering methods we will be completing unit 4. So stay on and stay put. Thank you everyone.